Hello all, this is Subramanian. In the previous video, we talked about DFMEA, Design Failure Mode Effective Analysis. Now let us dive into DFM. DFM is Design for Manufacturing. Every time when you engineer a component, you will have to design engineer in such a way that you complement the manufacturing process. Meaning, you will have to first decide upon what could be the manufacturing processes. For that, you will have to be competent on the multiple types of manufacturing processes about which we will talk. But once you have decided the type of manufacturing processes, you will have to have some design inputs with respect to complementing this manufacturing process. For example, if you are going to produce a plastic component, the basic thumb rule, I would say, this is just my terminology, the basic thumb rule or what you can follow is the draft angles can be minimum 0.5 degrees. This is out of experience, 0.5 to 1 degrees. When you are designing a sheet metal component, make sure that your draft angle is at least 7 degrees. Why is it so? Why should I have 0.5 degrees for plastic and 7 degrees for metals? Because this is going to be produced by a tool. Every tool has its capability. From a tool, you anticipate to produce some number of components out. When you follow these principles, it is easy for the tool to produce these components. The more you train a tool, the less number of output is what you get. It doesn't mean that if it is 5 degree draft angle for a steel component, you cannot produce the part. You can definitely produce a part even if it is 3 degrees. Make sure that it is not negative draft angle. You cannot produce those components. Or you will have to add an additional step for you to produce that kind of shape. When it is positive draft, bare minimum of 5 degrees or 7 degrees, you can easily draw the component, deep draw the component. If it is casting process, it is a different story. So the point is, you will have to give values on your components considering the material, the type of production process what you are going to follow. And this process of investigating and designing with respect to the production processes, manufacturing processes, considering tools life, considering tools output is called as design for manufacturing. You are complementing your production process for the part which you are designing, and that is called as design for manufacturing. You are designing, you are engineering a component considering the manufacturing processes already in mind. When it is plastic, there could be different set of design principles. When it is metal, there could be different set of design principles. And all those principles together, you are contributing or you are complementing for the production process what you are going to follow. And that is called as design for manufacturing. Hope you get an idea now. Let us talk about DFA in our next video. Thank you.